asking, what is supportive care? Well, the way that we like to think about it is that supportive care is all the stuff that isn't the directly anti-cancer treatments. Or, as I say when I'm talking to my colleagues working in medicine and research that are focused on the sub-epitope of chromosome 63 with its third little wibbly bit on the side, supportive care is keeping the kids alive while your treatments try and kill them. Now, there's something quite astounding about that. Because if you look at the treatments for acute lymphoblastic leukemia, and the way that they... Did I not switch on my thingy? I'll just have to be very, very loud, rather than amplified loud. Thank you. If you look at the way they leapt up from the early times in the 70s and 80s up into the 90s, that's the first graph in the survival curve as you go out over time, and then it leaps upwards in different eras of time. The first leap has no different chemotherapy in it. It has antibiotics, so the children don't die of infection. It has better blood products, so we can support them and intensify the chemotherapy. It has better anti-sickness agents, so that people don't stop having their chemotherapy. Supportive care saves lives. What I do is a lot of systematic reviews. Now, many of you will not have heard of what a systematic review is, and so this is a short demonstration of why a systematic review might be a good thing. Right. Lots of different studies happen in the world. This is a graphical representation of lots of different studies. First, the surname of the author, and then the year it was done. So, Froggatt 65, Froggatt published a paper in a medical journal in 1965. Across the bottom is the times more likely you are to die. 10 times more likely to die. 5 times more likely to die. If you're on this side, you're like a half as likely to die. So whatever it is they're studying is making you more likely to die. Got it? Right. The blobby bit in the middle is the best guess from that study, but because we've only taken a few people, we're not quite sure what the answer is going to be. It's a bit like an exit poll. You've got to have got an idea what you think the answer is going to be, but there's a sort of uncertainty in it. Well, we've calculated the uncertainty and put it in as wings. Right? I should probably do a statistician impression now and speak like this without my top lip moving and make my hair all slightly strange. What do you notice about these studies? They're all quite wide. They're all on the bad side, aren't they? Yeah? So they're not very sure, but it looks like it isn't very good. What will they have studied? From 1965 to when Wigfield, before she started her pop career, published in 1990. Yes, that is only for the over 40-year-olds. What was studied over all that period of time that was causing death so many times? What might it have been? Chemo drugs? Could have been, but it wasn't. Side effects? It wasn't, no. Infection? Oh, it might have been, but it wasn't. It's not directly cancer. Nutrition? Could be like poor nutrition? No. Drug trials. Taking part in drug trials, increasing it. No. Pharma's bad, but it's not that bad. No. No, this is the sleeping position for babies. Yeah. This is the sleeping position for babies. This is if you put your baby down to sleep on its back, not on its back. These are the studies that showed that putting your baby down on its side or on its front increases the risk of sudden infant death syndrome. People looked at them and went, well, they're on one side, but look at this. Look at the uncertainty involved. Look at how unsure we are. That can't be right. If they'd have done a systematic review and instead of just taking one study, added it into the study before, that's what you would have shown. By the early 70s, people would not have been going round going, the best thing to do is put your baby down on its front so that if it vomits, it will come out. they would have been going, put your baby down on its back. It might have a funny shaped head, but it'll be alive. Systematic reviews save lives as well. 100,000 babies in Western Europe and America probably died because we gave inappropriate advice. Children with cancer die as well. They either die of their cancer or they die of something else. And when we're trying to work out where to go next with the trials to make things better, what we really need to know is, why are those children dying? Are they dying of cancer or are they dying of something else? When you look into the literature, you find that people define death from cancer or death from not cancer in different ways in different studies. So you can't easily pull it together. You can't easily say, by going in and looking at the studies, which is the right target. Should we be doing more anti-cancer stuff, or should we be looking at saving lives because of complications? What we did as an international collaborative is come up with a system that defined what is a cancer death, what is a non-cancer death. And then we took it to a different group of people to see, could they make it work? You know the thing about your washing machine? You can use your washing machine, can't you? You know which of the two programs that you ever use in the 74 that are there. It's like brights and whites, isn't it? And you know it. You go to someone else's house, they've got a different washing machine. And yeah, it's the same with science. We made this thing work brilliantly with us. What we weren't sure about is, if someone else's washing machine was there, would it really work? Would other people be able to do it? So there's a scale that goes from 0, bollocks all use, to 1, so perfect it must be cheating and the Russians have interfered. We get 0.92 when we take this out. This is stunningly good. This is better than 2 teachers marking the same piece of work for a GCSE or A-level exam. This is incredibly impressive. This is what we've done in order to make things better by driving the science forwards. To improve supportive care, we need to know what we're doing, and we need to make the methods of science better, as well as the methods of supportive care. It all comes together to push us forwards. Just as a slight aside, anybody ever had an ultrasound done, or seen an ultrasound yet? Where they look at the thing, and it looks a bit like, and you go, and an ultrasound person goes, oh yes, that's an echoportexia, calcium, and you go, huh? Yeah. That's actually a weather map. That's a radar showing a typhoon coming in. And what I would advise you to do is always don't believe the speaker. Ask for evidence. Check everything that comes through, particularly on Facebook. But always ask, is it really true? Because it might not be. Investigate for yourself and critically analyse what comes through. Just a little hint at the start of the day, not to put everybody else off. Thanks, Susie. That's just a strawberry. It does remind me that I'm not going to talk about nutrition, but nutrition is an important part of supportive care as well. That's a cat. Cats are calming. This is because I'm about to talk about statistics. And there needs a bit of pre-medication going on. Anybody shopped at Aldi and Tesco? Yep. Okay. Of the two, which one is cheaper for your standard shop? Probably Aldi. So Aldi, then Tesco. Anybody shopped at Waitrose? I'm looking for a professor here. Waitrose and Tesco? Do you know what Tesco is?
Or if you buy Shop's own brand, if you buy Shop's own brand, Tesco will be cheaper unless you buy their higher range brand. If you get, for example, Market Extra, if you get Heinz Market Extra, it'll be the same price as Waitrose or Tesco. What's more expensive than Tesco is the veg, fruit and veg, much more expensive than Tesco. Oh, sorry, a Waitrose, but the Tesco stuff lasts half as long. So
let's go with that one. Waitrose more expensive than Tesco. Anybody shopped in... If we're talking about vegetables. Anybody shopped at Aldi and Waitrose? No? Good. Right, even if nobody shopped at Aldi and at Waitrose, do we know that Aldi will be cheaper than Waitrose on the basis of the information we have so far? Yeah. Yeah, until about 5 years ago, science said, you don't know the answer to that. You can't work it out. Fortunately, statisticians came along and they explained to us that you can know the difference. And so what we did was we took a whole bunch of antibiotics that we use for febrile neutropenia. You know, when you turn up hot, might have a bad infection. Oh, awful. Where's my pregnancy bag? Come in, get antibiotics. What we used to do was 2 antibiotics all the time. Other people use different antibiotics. These are all the trials that compared them. The lines are the links between the different types of antibiotics that you can use. We put them all together using the sort of Waitrose vegetable in Aldi type model of statistics, and we came up with the answer that using tazobactam, tazobactam on its own was more likely to make you alive than using it in combination with other drugs. And people went, what, using one antibiotic's better than two? That can't make sense. But the science said so. And a few brave people started dropping the second antibiotic. And they found that fewer kids were going to intensive care with knackered kidneys. And it looks like science actually works. And by pulling science, amazing, isn't it? Pulling information together, we get steps onwards, so we actually make a difference and we save lives. Now, febrile neutropenia is the point where you come in and you are like white lights. You have no idea what's inside there. And as you go through, you split into those on the dangerous end of the spectrum that need to go to intensive care and really need treatment, and those that just had a cold and need to go home, or even worse, just had a flick on the thermometer and didn't really have a temperature in the first place. What we have are a series of tools that we can use to separate out and distinguish between the high and low risk. But we want to know, are we using the right tool for the job? This is a bunch of kids that are turning up with febrile neutropenia. It's going to be statistics. About 1/5 of them will have a serious infection. Using our best tool, we can separate them into a high-risk group and a low-risk group. The low-risk group being only 8%, half the chance of infection. So one in that group, they might be treated with a very short time in hospital, maybe even sent home to be treated, and only that one brought back in. What about teenagers? Always look a bit odd, don't they? Particularly if they haven't washed for a while. Well, there are fewer teenagers in the studies, so we're not quite so sure. Even more confusingly, the teenagers tend to get lumped into either the adult studies or the children's studies, so we can't really see them. And so what we do is we go out there and we get all our mates together, the ones who did children's studies, the ones who did adult studies, and we get their data and we bring it all together. So then we can pick out all the teenagers from all those different studies, put them together, and we've got enough to actually work with. We then do maths, not quite with a Babbage engine, but with something almost the same that works out how does this work in teenagers as well. Remember the kids? 20% split into an 8% low-risk group. Do that with teenagers, you end up with not really having the same effect. It's important to investigate when you have different things, does it work differently? You shouldn't assume that everything's always going to be the same. We try not to in supportive care. We might want to use some complicated science stuff. Maybe a blood test that tells us the red ones are the people with serious infection, the blue ones are the people without serious infection, that tells us the difference between those people with serious infection and those people without serious infection. This is a duck. It's a pretty duck, isn't it? This is a yak. It's quite a pretty yak. If you take blood from both of them, and you do a whole genome sequence, where you look at every individual bit of DNA within the 2 blood samples, you can tell in 3 or 4 days which one of them is a duck and which one of them is a yak. There are other ways of telling that as well. What we need is research that really makes a difference. How much does that blood test add on top of what you've already got? And so I want to leave you with a study that is currently ongoing, explained by an 8-year-old.
Hello, my name is Ted, and I am here to tell you about research studies that is going on at Leeds Children's Hospital. When you are having chemotherapy, and you might get poorly and feel really hot or unwell. If that happens, your mum and dad will have to bring up the hospital. You'll need to go to hospital in case you have any bad infections. At hospital, the nurses and doctors will see you. They will always do blood tests and give you antibiotics and your line. You need to stay in hospital and have antibiotics until everything has got better, and then you can go home again. The research is to see if a special blood test that the nurses could take will help them to tell who is really poorly and who is just has a cold and could go home sooner. If you and your mum and dad agree to take part, if you come into hospital with a temperature, then we will take an extra tube of blood. The scientists in the lab will then do the special test on the extra blood. Later, we will tell all the other doctors about this in meetings and by writing an article which is like the news for doctors and nurses. You can ask your mum or dad or the doctors or nurses questions about this study and you don't have to take part. Thank you for watching and remember to like us if you liked it.
Just one final thought. Does this actually make a difference, explaining research like this, using little videos and stuff? There's a study to work out whether it does or not. Thank you very much.